This is CAD Design Software's demonstration of a single-layer BGA design. Upon starting CAD Design Software, the Read Technology file box will appear. Select the PCB one-layer millimeter technology file to set up the design environment for use with one layer and millimeters as the drawing units. Pick Open. Save the drawing. We'll call it BGA 200 underbar single layer. Pick Save. We review the additional technology settings. We can see we're using the PCB one layer millimeter tech file. These are additional settings for global parameters. We'll set the reference designator text size to 0.5 and pick OK. Next, we'll create the die that will be used in the BGA pattern. CAD Design Software Hybrid menu. Pick the Die Whiz command. Pick the Select Input File button. And we'll use the provided file die200.txt. Click Open. And we'll adjust the sliders accordingly. First, we'll type in the die length and die width, which will be 7. The component baud pad length and width will be set to 0.09. In the input units, we'll select millimeter. In the pin number slider, we'll set that to 3. The X coordinate, we'll set that to 1. Our Y coordinate, we'll set that to 2. The skip header lines, we'll set that to 2. And we can see we're set. We'll pick the right output file and we'll save this as die200.liq. Click Save. The text file will be output with all the coordinates. And now we can read this in to create the die outline pattern. We'll pick OK to exit the Die Wizard dialog box. Next, we'll read in the LIQ file to create the die outline. Go to the Hybrid menu, pick the Die Make command. In the LIQ die file control area, pick the Read File button. Pick the die200.liq file, pick Open. We'll press Enter to accept the default of its origin and the insertion point. We'll press Enter. We'll pick Exit. We can see our die, 200 pin die. We'll repeat the Die Make command. We'll save this new die to a new library. We'll call it Single Layer BGA. Click OK. And in our new library, we'll save the die as die200s. Pick Save. And the die has been saved to the library. Next, we'll create the boundary edge for the package, and it'll be placed on the PCB layer. We'll type PCB edge and enter on the command line. We'll press Enter to accept R for rectangular. In our size area for the horizontal and vertical, we'll accept the default of 27. And we'll accept the default layer of PCB and pick OK. And the outline is now created on the PCB layer. Next, we'll use the ball grid command to parametrically create a ball grid pattern. Then we'll block and place it into the drawing. We'll go to the CAD Design Software, BGA menu, and select the ball grid command. In the block name, we'll type in BGA 240S. We'll assign the reference designator automatically to B, and we'll set our pin number text height to 0.15. And we'll pick the Edit Parameters button. Now we can customize our BGA. In the pad diameter edit box, we'll type in a value of 0.72. We'll set our rows and columns to 19. We'll set our void rows and columns to 11. We'll make sure that we use a BGA package. Our position of A1 is in the upper left. Then we'll pick the Graphic Selection dialog box button, and we'll select our 4 corner pads. We'll pick OK. And with these pads now selected in our list, we can delete them so they will not be used. We can view our graphic again and see that the 4 corner pads have been eliminated. Pick OK. Pick OK once more. Then we'll pick the Create and Block button. And we'll accept the default placement of 0, 0. We'll press Enter. And we can place an additional pattern, but we'll press Enter to exit the command. And now we have our pattern. Next, we'll create the attach pattern from the LIQ file that was made previously. We'll go to the CAD Design Software, Hybrid menu, and pick the Attach command. We'll use our library single layer BGA and our Die 200S. Pick Use Selected Die, and we'll press Enter to accept the defaults for the position and rotation. In our fan out type, we want to use the fan out of straight equal pitch angled. And in our pad shape area, we'll make sure that our pad length and width is set to 0.35 and 0.1. Click OK. In our pad to pad gap edit box, we'll type in a value of 0.06. In our group side parameters, we'll edit all of the following by double picking. And we'll set our maximum distance to die to 1.75. Our pad to pad gap will be set, and our pad length will already be set. We'll pick OK. Now we can calculate the positions. We'll pick the Calculate button, and we can add the pads. Click OK so we can view our temporary attach pattern. And we'll return to the attach command. And we'll save this to our library with the name ATT200S. We'll pick Save. And now we're ready to place the attach pattern in the drawing. Next, we'll use the Place Attach command to place and block the new attach pattern. Go to the Hybrid menu, pick the Place Attach command. We'll select our single layer BGA library, and we'll select our ATT200S. We'll set our reference designator to U1, and we'll pick Place. We'll press Enter to accept the default position of 0, 0. And the attach pattern is now placed and blocked in the drawing. Next, we'll create some fiducials in the design. We'll go to the CAD Design Software, BGA. We'll use the fid bond command. In the block name edit box, we'll type in the name of fid1. We'll uncheck the reference designator. We'll pick the Edit Parameters button. We'll select a cross type. We'll set the length and width to 0.25. In the centerline scale, We'll set this value to 1.0. We'll select a square mask and we'll set the offset value to 0.05. Click OK. Click the Create and Block button, and we'll place these by coordinate. Type in -5, -5 and enter, and 5, -5 and enter, and enter to exit the command. We'll do one additional fiducial. We'll return to our fid bond command. We'll change the name to fid2. We'll pick the edit parameters button. We're going to select a filled triangle. We'll set the length to 1.0. We'll pick OK. And we'll create and block. We'll type in our placement coordinates of -12.5, comma 12.5. We'll type R and enter to rotate. Type in a value of -90. Press enter and enter once more. We'll use our refdes command. Type ref des on the command line. We'll type F1 and enter. We'll select our components. And now our fiducials are placed. Next, we'll use netlist gen command to create a netlist between the BGA and attached components. We'll go to the BGA menu and select netlist gen. We'll select our first part, which will be our attach pattern, and enter. And our second part, we'll pick select. We'll pick a pad. We'll select the store new netlist and drawing, write new netlist to file, and the draw rats checkbox. Then we'll pick the create nets button. Following pins failed to connect, we'll pick OK to accept this. We'll be prompted to write our netlist. We'll accept the default format of EPD. We'll pick write netlists. We'll save this as BGA 200 single layer underbar new .net and pick save. And our rat lines have been drawn according to the program creating the connections between the attached pads and the ball grid pads. To be certain that these nets can be routed, we'll use a predefined netlist to read it in. We'll use the netread command, and we'll pick the provided single layer.net. We'll pick the rat command, and we'll draw our rats. Next, we'll create the preroutes from the attach pattern to the BGA. Go to the BGA menu and select preroute. We'll select near side balls in our global parameters area, the equal spacing checkbox. We'll select all 4 of our sides and pick the edit selected sides button. In the straight distance edit box, we'll type in a value of 1.0 and 12.0. Minimum ball gap will be 0.06. The final straight distance will be 0.33. The angle final construction line will be 30. And we'll pick OK. And then we'll pick OK once more. Create. And now our preroutes have been drawn. We'll run the rat command to re-optimize these rats. Type RAT and enter. We'll pick the draw rats button. Next, we're ready to route the design with the AutoTrack command. Go to the CAD Design Software, Software Utilities, Interactive Route, and we'll pick the AutoTrack command. Type C and enter to configure. We'll make some additional settings here. We'll pick the multiple selection, fix each trace, push automatically, and sort by length. For the direction, we'll use automatic follow connected polyline since we're using preroutes. And we'll select the first 4 autofix types, different angles that it will fix while it is routing. And we'll pick OK. We'll type G and enter for general selection, ALL and enter to select everything, and enter once more. Press enter when the AutoTrack command is done to exit the command, and we can zoom in and check our routes. Next, we'll check our connections using the netcheck command. We'll go to CAD Design Software, PCB, Net menu. We'll pick the netcheck command. In the shape-based capture area, we'll select the Capture Full Copper checkbox, and we'll capture the PCB netlist. We'll compare the newly captured netlist with our provided netlist. Click Open. Then we can pick the Analyze Errors button. We can see that there are no errors. There's a K error. These are the newly added fiducials, which were not in the netlist, so we'll accept this error. And we can pick OK to exit the command. Next, we'll check for clearance errors. We'll go to the PCB check menu. We'll pick DRC. We'll select our set clearances. In the Ignore Errors Less Than edit box, we'll type in a value of 0.001. I'll pick Set. We'll select our standard objects from first to second object. In our minimum clearance, we'll use a value of 0.06, and we'll set that specified value for all of our clearance rules. We can pick OK. Pick OK once more. We could run our DRC, and we'll encapsulate the drawing and press Enter. We'll receive a report if there were any clearance errors violated, and we have no DRC errors found. Next, we'll create the solder masks for the BGA pads and attach substrate bond pads. Go to the CAD Design Software, BGA menu. We'll select the Mask BGA command. In our minimum mask width, we'll set the value to 0.1. Our outer gap will be set to negative 0.05. Our inner air gap will be 0.05. The side air gap will be 0.05. Minimum segment length we'll set to 0.01. In the BGA pads mask opening diameter edit box, we'll type in a value of 0.62. And we'll activate and create for substrate bond pads and the ball pads. Click Create. Now that the masks have been created, we use our LX command to view just those artworks. We'll type LX and enter, and we'll select the MN code for the solder mask near side and pick OK. This will turn off all layers except for our newly created masks. Finally, we're ready to output our design to Gerber files. We'll go to the CAD Design Software, Conversion menu, GerbARX, and pick the GerbOut command. We'll pick the Automatic Setup button, and we'll purge any unused layers. We'll receive a dialog box that shows us what the report will do. It shows that we have one layer and the layers that will be output, and pick OK. We'll pick our mask near side sub-batch, and we'll need to edit this. We'll select it in the layers and sub-batch and pick the settings for selected layer. In the activate area, we need to turn on the flash circles option, and we'll set this to non-blocked. We'll turn on our fill control, and we'll pick our fill control button. We need to set this to a polygon fill allowed maximized, and we need to fill all zero width polylines. Pick OK. We'll pick OK once more, and we can see that now there's an asterisk next to our layer, meaning that it has been modified. We'll pick OK. Then we'll pick the convert button. We'll receive a last warning that some layers were not included in any sub-batch. We'll pick OK. We'll receive a report during the Gerber out if there were any errors, but it shows that we did output all of our photoplot files. Now we can look at our Gerber files using the GerbView command. We'll start a new drawing. We'll pick cancel on the read technology. We'll go to CAD Design Software, Conversion, GerbARX, and we'll pick the GerbView command. We'll select our master aperture file, which is our BGA 200 single layer rep, and pick open. We can pick view, and we can see our Gerber files. If we return to the GerbView command, we can select individual layers and isolate them to view the Gerber individually. Look at our mask. And this concludes the BGA single layer demonstration.